the oxidation of iodide ion by peroxide sulfate ion.
The objectives are to determine how the concentration of a species and the temperature can affect reaction rate in the determination of rate law and rate constant.
As in most redox reaction, products are strongly favored, so you don't have to worry about the occurrence of reverse reaction.
The easiest molecule to use as monitor of the rate is iodine product, since it forms a blue complex with starch indicator. In a moment, there will be gradual buildup of blue color as iodine product accumulates.
Moving on to the actual experiment, it is recommended to do a jotter beforehand.
The apparatus we use were beakers, 250 ml conical flask, measuring cylinders and the stopwatch.
Chemical we use were 0.2 mol of potassium iodide solution, 0.1 mol of potassium peroxide sulfate solutions. (0.05 mol of sodium thiosulfate solution. In addition, we also use distilled water.
To determine the relationship of the concentrations of the reactant to the reaction rate, the initial rate method should be applied, wherein it used the rate law.
Where K is the rate constant and the formula in the brackets are the concentration of iodide and peroxide sulfate ions respectively. The power of X and Y are the order of the reaction with respect to the ions. In addition, the rate law describes the dependence of rate on the concentration of the reactants. This means that the concentration of iodide ions and peroxide sulfate ion is directly proportional to the reaction rate.
Moving on to the procedure, the beakers must be labeled correctly with respect to the solution. Then, the solution was measured by using a measuring cylinder based on the data given.
Create a systematic working place for a smoother flow of the experiment.
Since you must time the reaction, you should first pick up a solution containing the iodide thiosulfate and any water needed, and then finally add the peroxide sulfate. Begin timing as soon as the peroxide sulfate is added, and immediately swirl the reaction to ensure good mixing. Stop timing when the solution changes to blue. Keep in mind to always dispose the solution correctly.
Perform at least 2 runs of each trials or until reproducible reaction times are obtained.
Note that the trial 1 serves as a reference reaction mixture.
Repeat the steps and record all data. We've created a system for a smoother experiment flow, whereby the experiment was carried out in pairs, where one person will do trial 1 to 4 and the other will do trial 1, 5 to 7. The volume used for the preparation of each trials are in the description box down below. As you can see, the reaction is a transition from colorless state to a blue solution. This is due to the addition of sodium thiosulfate. The purpose of sodium thiosulfate was to consume all iodine formed from the reaction of persulfate and iodide. Once all the thiosulfate has reacted, iodine then will react with starch to form blue complex. And voila, you have yourself a blue solution.
The next thing that was needed to be done was finding the order of the reaction.
The initial rate method was performed to obtain the reaction orders, therefore completing the formula of rate law.
Moving on to part 2.
In part 2, the objective was to determine the effect of temperature on the reaction rate of persulfate iodide system.
For this run, use the reference reaction mixture. Before adding the peroxydisulfate, warm the mixture containing iodide and thiosulfate using a hot plate or cool it using an ice bath.
And let it sit for about 5 minutes. In the meantime, while waiting for the solution's temperature to drop, we recommend to clean up the working place. After the 5 minutes mark, remove the conical flask containing the solution from the ice bath.
Begin timing as soon as the peroxydisulfate is added, and immediately swirl the reactions to ensure good mixing.
From the data we've gained, it demonstrates that as the temperature increases, the reaction rate increases as well as the rate constant. Higher temperatures are favored by reactions due to higher degree of collisions. Therefore, faster reaction rates happen when the degree of collision is high.
Stop timing when the solutions change to blue.
Record the temperature just after timing the reaction. And that is it for experiment 3, kinetics, factors affecting rate of reaction. That is all from us, group 1, checking out.
It's a wrap!